students, how are you all? I hope you are doing absolutely fine. So, welcome all of you at AriserTalent, and I'm Krina discussing about the physics chapter class from which belongs to your class 10, that is about the electricity. Now, until now, what we have discussed in our previous lecture, we have a discussion about the resistance, resistivity and conductivity. We have gone through the definition of these terms and the units belonging to these terms. So what you have to do, you have to learn the formulas of these terms so it may be easier to you to do the numerical problems we have in this chapter. Now let's start with the another topic we have, that is about the combination of resistances, and this is very important topic because from the competition point of view, from your CBSE point of view, a lot of questions arises from this topic, and this topic, particularly the combination of the resistances, carry a maximum marks here. It means a large marks question will be asked from this, whether it may be a 4-mark question or 5-mark question in your exam. So let's discuss about the combination of resistances. Now, combination of resistances means combining the resistances. So we can combine the resistances either the lengthwise or we can combine them in the parallel. It means one above the another. So there will be the two combinations possible here. One is the lengthwise and another is the parallel. So if we are doing the lengthwise combination of the resistances, we will call it as a series combination. But if we are connecting the resistances in the parallel, we may call it a parallel combination. So for the combination of a resistance, we have the two categories here. First category is known as series combination, and the second category we have is about parallel combination. So these are the two categories we have regarding the combination of the resistances. So these will be our two categories. Now, firstly, let us know about the series combination you have. In case of the series combination, you will connect all the resistance in a series connected with a source of supply, that is battery, and the same value of the current will be flow through that conductor. So what will be the law of series combination states that when you connect the resistance in the series, the equivalent resistance of a system will be the sum of all the resistances, keeping the current same, but voltage across each conductor will be the different one. So let's discuss about our first category, that is about the series combination. So the first topic is about resistance in series. Now, what is the law of series combination of resistance states that when resistance are connected lengthwise means in a series manner, then equivalent resistance or total resistance will be equal to sum of all resistances across each resistor. It means that total resistance or series resistance will be equal to the sum of all the resistance in the circuit. But what you have to remember, the 2 points about this. First one is you have to keep the current same in all resistors, and second, you have a different value of the potential difference across each resistor. Now, let us draw a circuit diagram for the series combination we have. So, what I am doing here, firstly, I have taken a 3 resistances. This is a symbol of resistance we have. I have connected these resistances with the source of battery. So, this will be the diagram for the series combination of the resistances we have, and what we have taken here, this is a source of battery we have. This is our battery. This is having a positive sign, negative sign, positive sign, negative sign. This is our resistance 1, this is resistance 2, and this will be our resistance 3. Now, what the 2 points we have considered here, in the case of series combination, the same current will be flow throughout the conductor. So, the current will be flowing like this, that is I, and in the entire system, the current that will flow will be I. But what you have to keep in mind, that voltage drop across each resistor will be different. So, voltage here will be V1, here voltage drop will be V2, and here the voltage drop across the circuit will be V3. So, these are the value of voltages across in the circuit. Now, you have to derive an expression for equivalent resistance or total resistance of the system. So, let's do the derivation here. What we are doing? Derivation for equivalent resistance. Now, from Ohm's law, we know that our value of voltage and I are dependent to each other, and from that derivation, we will get that V equal to IR. What Ohm's law states that? According to Ohm's law, V is equal to IR. This is the statement we have. Now, what we are doing? We are calculating the voltage drop across each resistor in this system. So, if I am going to calculate the voltage drop across R1, I am calculating voltage drop across resistor R1, it came out to be, what is the voltage drop across the resistor R1? We will get V equal to IR1. This is our equation number 1. Now, we are calculating the voltage drop across R2. Voltage drop across R2, and that will be equal to our V2, and it came out to be IR2. I is the current and R2 is the value of the resistor we have. Now, in the third case, we are finding the voltage drop across R3. And what will be the value of R3 here? V3 here. V3 here came out to be IR3. So, this is our equation number 3 we are getting here. So, these are the 3 equations of the resistances we are getting here, that the voltage drop across V1 will be equal to IR1, this voltage drop will be equal to IR2, and this voltage drop will be equal to IR3. So, these are the 3 drops in case of the series combination we have. Now, what we have to calculate? We know that the voltage will be different in all these cases, but the value of the current will remain same throughout. And we have to calculate the equivalent resistance in all these cases. So, let's do the further part of the derivation, but just copy this from here so we can proceed to the next part. Now, we have calculated the voltage drop across each resistance. And the three equations we are getting from there. And our first major equation is this. This is equation number A, which is its equivalent to the Ohm's law we have. Now, this V equivalent, it means voltage drop that is equivalent will be equal to V1 plus V2 plus V3. Total voltage will be equal to voltage drop across the three resistances we have, that is R1, R2 and R3, and it is V1, V2, V3. So, this is the general equation we have. Now, substituting the values from all these equations to this formula. So, what we are doing here, substituting values from equation A, 1, 2, 3 here. We are substituting these values here. So, what we are getting here, we will get here V equivalent equal to IR equivalent equal to IR1 plus IR2 plus IR3. This is the equation I am getting on substituting these values. Now, you can see that IR1, IR2, IR3, all these terms have a I common in them. So, we can write it as IR equivalent will be equal to I common R1 plus R2 plus R3. Now, this is the equation which is equal to both the sides of the equation. I will be cancelled by I, and what I am getting here, R equivalent will be equal to R1 plus R2 plus R3. So, this R equivalent is actually the resistance in series, that is RS. And this RS will be written as R1 plus R2 plus R3. So, this is the basic derivation and important formula we are getting for the series resistance we have. This formula is very important for calculation of the combination of the resistance and series, but what you have to do, you just have to keep in your mind that in case of the series combination, we have the same current flowing through the entire system, but the voltage drop across each resistance will be different. So, these are the two conclusions we can write here. These two conclusions are current same but voltage drop different. So, these two things you have to keep in mind before doing such derivation. So, this is the derivation of the series combination you have. In your exam, numericals may be asked from this topic, and sometimes in your CBSE or the school level exams, simply derivation may be asked, derive an expression for the resistance in the series. So, what you have to do? You have to just simply add the three resistances. Suppose I have given the resistance of 1 ohm, 2 ohm and 3 ohm, and they are connected in the series with a supply. So, what I am doing? If I am going to calculate the equivalent resistance, it came out to be 1 plus 2 plus 3. What it will give? It will give you a 6 ohm. You have to just simply add the resistances in the series here. So, this is all about the resistances derivation which is connected in series. So, copy it from here so we can discuss about the resistances in parallel. Now, let us derive an expression for the combination of resistances in parallel. Now, what happens in case of the parallel combination? We have seen in the series combination, the current flowing through each resistor will be same, but in case of parallel combination, we will see that different current will flow through the different components attached to the system, but voltage across the system will be same, and in parallel combination, we will get a different equation as compared to the series combination. So, first discuss about the circuit diagram for the combination in parallel. So, let us draw the diagram here. Now, this is a circuit for our parallel combination, and you can see here that all the three resistances are connected in parallel. So, we have this resistance R1, this R2 and this R3, and this is a common supply of battery that is having a voltage V. This is our positive terminal and this is our negative terminal. Now, when the current start flowing from this circuit, the value of the current is I, and when this current flows from this circuit, it is divided into the three parts, that is I1, I2 and I3. It means the same current will not going to flow in all the three resistances. So, we can say that in case of the parallel combination, we have different value of resistance, different value of current here. This is our parallel combination. Now, again in parallel combination, we will calculate the value of the resistance in each case, that we will calculate the value of Rp, it means resistance in parallel. But what will be the rule for the parallel combination? The total current in the circuit will be the sum of current through each resistor, but keeping the voltage drop across each resistor will be same. In case of parallel combination, we have the same voltage supplied to each resistor. Now, what we will do, we will firstly calculate the current. Firstly, we will write the Ohm's law here. V equal to IR. Now, we have to calculate the different values of current in the resistor. So, what it came out to be? It came out to be I equal to V upon R. So, this is our Ohm's law. Now, in first case, value of current in resistor 1. If I am calculating the value of current in resistor 1, it came out to be R1 equal to I1 equal to V1 upon R1. I1 equal to V upon R1, that is our equation number 1. Voltage is same, but in case of I1, which resistor is connected here? R1, so I1 equal to V upon R1. Similarly, current in resistor 2, what will be the value of current in resistor 2? It came out to be I2 equal to V upon R2. This is our equation number 2. Now, we are calculating current in resistor 3. It came out to be I3 equal to V upon R3. So, this is our equation number 3. So, these three equations we are getting for the value of I1, I2 and I3. Now, the law of parallel combination states that the total current in the circuit will be the sum of all the three currents. So, I can write here the total current will be equal to I1 plus I2 plus I3. So, in parallel combination, we have to add up all the currents, but in series combination, what we have done? We have added all the voltages we have. So, this is the general equation we have. Now, this I can be written as V upon R equivalent. So, I can write I equal to V upon R equivalent, and substituting all these values from equation 1, 2 and 3 here, what we will get here? V upon R1 plus V upon R2 plus V upon R3. Now, look at the right hand side of the equation. You can see that V and V are common terms. So, I can write here V upon R equivalent is equal to V. In bracket, we will put 1 plus R1, 1 plus R2 and 1 plus 1 upon R3. Now, this V will be cancelled by this V because the equation is equated both the sides. So, I can write 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So, this R equivalent is nothing but the resistance in parallel. So, I can write finally here that Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And this Rp is actually the resistances in parallel. This Rp is our resistance in parallel. So, you can see that we are getting just opposite equation as in case of the series combination, because in series combination we have just added the voltages, but in case of parallel combination what we are doing, we are adding the currents, and you can see that in case of parallel combination we have taken an equation that current is inversely proportional to resistance. That's why we are getting 1 upon R1 plus 1 upon R2. So, this is the resistance in parallel. So, you have to learn both these equations for calculation of the numericals. But in case of parallel combination, what you have to do? You have to remember just 2 points. Voltage will be same and current will be different. So, these are the 2 important points to remember here, that voltage same and current will be different. So, this is the equation of resistance in series and resistance in parallel we have. So, for doing this type of derivation, firstly you have to write the things you have given. Secondly, you have to draw the circuit diagram with all the specifications I have done. And finally, we will arrive at the point where we are getting the final equation for the derivation. So, this is all about the resistance in series and parallel we have discussed in today's lecture, and this is very important topic from your both exams, competitive as well as your CBSE exam. So, this lecture is over for today. We will deal with many more problems in our next lecture. Thank you so much and have a nice day.